Yeah, all right. Good morning, everybody. Thanks for coming out. My name is Julia Schwartz, and I'm an engineer, and I work on input and interaction for HoloLens.
Hi, everybody. My name is Andre Borden, and I'm an engineer in Mixed Reality Toolkit. So today, we're going to talk about mixed reality. It's a new form of computing that Microsoft has been developing for the past several years. But before I continue, who here has seen the HoloLens 2 launch event, the videos? Yeah? You remember the amazing HoloLens video? It was just beautiful. I love it. You guys like it? Yeah. Cool. Do you remember Julia from that event? Great. She'll talk more about that. All right. So then, as you know, HoloLens and mixed reality computing is basically when we blend the digital world with the physical world. So, I mean, consider this. Right now, we're looking at a 2D screen for content, for digital content. It may not be the best to, for example, interact with the solar system, to inspect the solar system. All interaction is often indirect. You use a keyboard and use a mouse. But with HoloLens 1, we put holograms, we put digital content into the world around you. Yes, exactly. And that means that solar system can be right here. And then with HoloLens 2, we went even further. We enabled instinctual interaction. We allowed you to touch holograms. So consider this. Let's say I have that solar system right here. We have the sun, we have Earth, we have Mars, we have a car. If I wanted to interact with the Earth, the instinctual interaction would be to pick it up. Now that interaction with holograms, that interaction with digital content, not only it's direct, it's natural to us. It's computing that's natural to us, as it should be. And using these two capabilities, mixed reality developers today are building unique experiences to solve real-world problems. And they're bringing into fruition what only recently was in the realm of science fiction, interacting with holograms. And what we're here to talk about is you, the mixed reality developers. Who here, by the way, has developed for HoloLens? OK, for the rest of you, welcome to a whole new reality of development. And that's what we're going to talk about. We're going to talk about the people that haven't developed for HoloLens and the people that have, and the tools we're building to empower you to build the next generation of experiences. One of those tools is Mixed Reality Toolkit. It's an open source project for Unity 3D that's built by Microsoft, by our team, and it gives you the ability to build new HoloLens applications very quickly, even if you're a new developer, or enhance existing applications. And out of the box, just opening up a sample scene, you can start playing with holograms, interacting with them, resizing them. We give you a lot of functionality. That's actually my favorite bounding box, the way it reacts. So Unity, as I'm sure many of you are familiar, is a game engine. It's for developing games, but it's also for developing mixed reality applications for HoloLens and Windows mixed reality, and there's other devices. Mixed Reality Toolkit is built to support HoloLens 2 and HoloLens 1 and Windows mixed reality. It also supports any device running on top of OpenVR. And we're making strides into supporting ARCore and ARKit. We'll show you some of that today. When I say out of the box, you get a lot. With Mixed Reality Toolkit that's available out there right now, you get buttons, you get a system keyboard, many, many different other controls. And the bounding box, it's built on top of UX guidelines that Julia will talk about later. And then you get a bunch of functionality. You got eye tracking, you got spatial understanding, teleportation, and many, many more. So with that, let's switch gears for a bit. Julia is very passionate about with human interaction with digital content. She participated in a lot of studies, did a lot of prototypes, did a lot of research, and today she's going to share with you some of the UX guidelines and learnings we've compiled over the years. After that, she'll talk about the Mobile World Congress, the video, and how simple it is to recreate that using Mixed Reality Toolkit. So, actually, out of curiosity. Yeah. So, HoloLens 2, personally for you. Yeah. What do you like the most about working with it?
Okay, what do I like the most about working on HoloLens 2? That's easy. It's definitely getting to work on all those input and interaction techniques and basically discover this new way of interacting with objects. For those of you that didn't see it, a couple months ago, we announced HoloLens 2 in Barcelona at Mobile World Congress. And this is actually a video of me getting to show all of those interaction techniques that we've spent years developing. And the thing I love about it is, I actually had to pinch myself before I went on stage and asked, was I dreaming? Because when you think about it, this kind of stuff is the stuff you normally see in movies, with like actors, waving their hands in the air on a green screen, and then they sort of, all the artists put that all up in post-production. But what you see here on stage, this is real. And what do I mean by that? I am literally seeing the holograms that you're seeing in this video. I'm actually interacting with those sliders, with the buttons that I'm pushing in. That's me. That's actually what I'm seeing. And that is really incredible. And in fact, to prove to you that this is real and it's not just smoke and mirrors, we're actually going to recreate the buttons that you see here and those sliders that you saw earlier today in Mixed Reality Toolkit. And so yeah, the thing I love about this too is that it's actually kind of incredible that we can do all this stuff, and it might look really easy, sort of when you see it here done like this. But let me tell you, it's actually was quite a lot of work to figure out what the right way to do these interactions was, sort of how you should actually interact with these interfaces. And we're sort of in the wild west of 3D UI and augmented reality today, and we're all discovering this together. Maybe in some time in the future, it'll all be commonplace and everyone's going to take it for granted. But right now, it's definitely not obvious. And when you get your devices, you're going to want to try like many different things. You'll be so excited, like I was when I started discovering all of this. And you absolutely, by all means, should try everything, because for sure, there were a small team of us working on this, discovering things, but there's hundreds of you, thousands of you. So you're going to discover new stuff, and I absolutely recommend that you try everything that you can and explore, and then of course, publish and share your learnings like we're doing here. But what I want to do today, before I actually get started in showing you how we coded this up, is give you a little bit of some guiding lights about where to get started. Sort of, you have all these ideas, but what are some grounding things that we've learned based on our own prototyping of the things that worked and didn't, for what's a good way to build interfaces for this. So I'm going to just provide some basic guidance. I am not going to have time to go over everything, and I'll tell you where is a great place for you to go online to go over the docs so you can see later on. And by the way, unfortunately today I'm not going to have time to actually show you all the prototypes that we built to get where we are today and to discover this model. But I gave a talk last week at MR Dev Days where we basically shared most of the prototypes that we built while we were discovering the ways to interact with holograms. And what we did is we shared a prototype, showed what worked, what didn't, and then the principle that we learned from it. So we're working to publish that all online and make it available. So I'm just really encouraging you to look up MR Dev Days, the hand interaction crash course talk to learn about that more. All right, so let's get started with the basic idea of this new input model, this new way of interacting. It's actually very simple. The core idea of HoloLens 2 is instinctual interaction. So you shouldn't need to learn how to use a device, you should just know how to do it. And it's actually quite simple, because you see these sort of 3D objects, and we know how to interact with 3D objects in the real world. You just reach out and directly interact with them. And that's the same idea that we have here with HoloLens. Now, as I mentioned before, I'm not going to be able to cover all of the details of all of our interaction principles that we learned. So just leaving this link here, aka.ms/mrdocs. This is the place where all of our design team is actually putting up all of this guidance. They're making gorgeous pictures and thinking a lot about the right way to interact. So I'm just going to leave this up here for folks to take a picture of and get that in their mind. But for now, let's talk about a couple of basic ideas that we're actually going to touch on a little bit in the demos today. So the first idea is very simple. Actually, it's great when you can have a very simple interaction model, because if it's simple, if it's easy to explain, then it should be easy to use. So the first idea is that you should be able to press buttons with your finger. Sounds obvious, right? But actually, when you think back to it, when I was starting out on 3D interaction, I actually started with Connect, like many of you probably did. So I was building all these 3D interactions of pressing buttons in the air, but mapping to a 2D UI. And that sort of disconnect of where you're doing these 3D inputs to a 2D output, in the end, sort of made the UI difficult to use. So the amazing thing about HoloLens is that now we have 3D input that matches to the 3D output. And that makes these interactions work much better. So when we demoed to press and all sorts of other folks at Mobile World Congress, it was really rewarding. So you would show someone a button, and you would say, just do what you think you should do what comes naturally. And people would just reach out and press the button, and it works. And they don't even get excited that it works. I get excited that it works. But they're just like, oh, of course, that's exactly what should happen. So this is sort of a very simple idea, but an important one. Now, the details of how to build these buttons to make them work well, that's actually sort of the devil's in the details for this one for sure. Some basic ideas are that it's very important to provide audio and visual cues. What do I mean by that? So visual cues. So it's very important to show via a proximity light where your finger is in relation to the button, sort of having a nice shader effect as if your finger had a light and it's sort of illuminating the button. And the reason is that sort of gives the user a sense of where their finger is in relation so that they can target better. We actually have a thing called the finger cursor that you'll see on HoloLens. It's sort of a ring attached to your finger that actually changes in radius as you get closer to the buttons and press them. And that helps communicate not only the location of the finger, but also how close it is to the interactive surface to help people target and click. I mentioned clicks. Sounds is very important for button interactions, actually. So it's very important to play audio sort of to communicate all the states of your buttons. So when on press, on contact, on press, on release. And the reason for this is because when you think about what you're doing, maybe some of you saw me earlier sort of testing our demo out, I'm just poking the air. So I'm not actually touching an actual surface. And because of that, we're missing a lot of that feedback that we get from our fingers when we're touching things. So we compensate for that by using audio and visual cues. So my usual piece of advice is to sort of crank up all of the other input sources that your brain can get. So the audio and visual to compensate for the fact that you're not actually touching something. And when we were starting out prototyping, we actually weren't sure whether that would work. And it turns out it does actually work quite well, that you can compensate for those things and have people successfully press buttons. And the data that I have to do that is we ran a lot of studies, but also I just know if people are able to press buttons. All right, spent a lot of time on that slide. We'll go faster on the rest. But I really, as you can see, I could talk about buttons all day, but we have to keep going. So when you get your HoloLens 2 or any sort of device that has hand tracking, you're probably going to want to stick a collider on every single one of your fingers and do something like type with all 10 fingers. And in fact, that's what we tried when we got our devices first. And what we learned very quickly is it's actually very hard to do very accurate interactions and typing. And by accurate, I mean when a user intends to press one of 3 buttons, like button A on the left, that they actually press the left button and not the one in the middle on the right. And the reason is because of false activations. And this is because on a surface, again, your fingers stop when they hit that surface. But in the air, they're all going to go through. So it's quite actually difficult to make the UI sort of recognize which finger you're intending to use for the press in a general way. And certainly this is a really active area of research, but a really good low-hanging fruit is just to have a collider just on the index finger of each hand. And the nice thing is that this actually works in many cases. So even if people use a different hand pose, like their full hand, to press a button, it's still going to work because the index collider is going to go through it. And in fact, I had a story where at Mobile World Congress, we had somebody try to press a button with their pinky. And I was a little worried, but actually it worked. And the reason is because the index finger still went through the button. So again, people thought, oh, I can press my pinky, but actually it's just the index finger. So this is a really nice trick that works quite well. So as I mentioned, there's a lot of details in buttons to actually make them work really well. And so luckily, in Mixed Reality Toolkit, we're actually providing with a button and also an input system that correctly assigns colliders to the fingers, so you don't need to worry about this, and we'll get into that a little bit later. OK, so push buttons with your hands. Now, how about moving objects? Another very basic idea. Grab objects directly with your hands to manipulate them. Now, something that's kind of interesting about grabbing objects that we learned when we sort of showed this to people in our studies was that the shape of the object actually really dictates the way that people grab. So for example, for a smaller object, people are going to do like a finger pinch, or maybe we gave the different gestures names. So this is our baby shark, kind of a open hand. And those are actually really easy to detect, so they're highly reliable. So grabbing small things, like small objects, generally tends to work quite well. When you go for the larger ones, people try to use the fist, which also actually works quite well with our hand detector. And now you notice in this diagram, I sort of stop at the hand-sized objects. But what if I wanted to pick up this podium here? So we asked people to do that. We would show people a large object, and we'd say, pick it up. And they would be like, OK, let me pick it up with both my hands, sort of like you'd pick up a real object. And there's a couple problems with that. First is that your hands are outside of the field of view of the HoloLens. So they're not actually going to see your hands if you do the bear hug style pickup. And the other problem is with these sort of framing gestures is that they can work. And I did implement something like this, but it's actually quite hard to do it well if you're also enabling two-handed manipulation, because when you're approaching something from the sides, it's ambiguous whether you intend to do a two-hand manipulation or a framing gesture. So then you end up building this UI that has a lot of ambiguous state, and while it's a very interesting research project, it can actually lead to a lot of complexity in the code and make it quite difficult to debug. So my advice about grabbing objects: absolutely grab objects to manipulate them. For larger objects, provide handles or obvious cues for people to grab instead of forcing them to grab the whole thing, because if you don't provide an obvious UI cue, they're going to treat it like a real object and try to pick it up like a real object. And in fact, what we learned when we ran studies where we basically showed people objects with and without these handles is that if you just need to show people handles once. If you show them once and then you hide them, like we have in our shell, we sort of have these handles that appear and disappear, they remember, and people are going to pick them up from that handle. But if you never show handles, people are just going to try to pick up objects like they were real objects, and that's actually going to be a lot harder to do reliably, although it is very interesting research. All right, next, going back to visual and audio cues, I'm just going to repeat myself because it's very important. Never some harm in that. Very important to provide visual and audio cues to communicate the state of your object. So for example, when you're hovering near a grabbable object, change the color of the grabbable so that people know that when they grab, that's the object that's going to grab. It's like basic stuff, it sounds like, but it makes a world of a difference. Also, playing sounds on grab start and end, very important, because again, you want to communicate the state of your system to your user. It's critical to do this in sort of holographic applications. For manipulation, you also want to support one- and two-handed manipulations. And sort of, this is a lot of detail, a lot of stuff to do, right? Supporting one-hand manipulation, two-handed, all those state transitions. Luckily, again, we're giving you the manipulation handler that is basically your Swiss Army knife of manipulation. It supports one-handed manipulation, two-handed manipulation, switching between the two. For those of you that used Toolkit previously, this is a combination of the drag and drop handler and the two-hand manipulation component. And it works both directly and indirectly at a distance, and it works on HoloLens 1 as well. Speaking of indirect distant interaction, another thing that we learned when we showed these sort of holograms to people, we would basically show them a bunch of holograms and say, how would you move that coffee cup that's on this side of your table to the other? And not surprisingly, we learned that people are kind of lazy, and they don't necessarily want to walk over and grab something directly. They just want to do this indirect interaction. So how do we interact with the distance on HoloLens now that we have these articulated hands? Well, we're using these hand rays. So you can think of that as, if any of you are familiar with VR and motion controllers in VR, you've got rays that are sticking out of those motion controllers. We do the same thing for the hands. So you've got a motion controller hand with a ray shooting out of it. And then when you get close to the object, the ray disappears and you directly manipulate it. When you move your hand away from the object, that ray shows up again. And now you're doing interaction at a distance. So it's really nice, sort of works both near and far. It's one single input model. We kind of like that. And in my MR Dev Days talk, I go to great detail explaining you all the different other ways that we tried interacting at a distance, and why we ended up with this, and why we ended up with the algorithm that we did. It's actually I'm really happy that I'm able to share all that with you, because it was the thing that you're going to want to do, that you're going to be like, oh, why are the hand rays not doing this? I wanted it to do this. There's a reason, and I talk about it in my talk for why. So again, in Mixed Reality Toolkit, we are providing you with the hand rays. And again, I'm showing you the motion controller, because we do in Mixed Reality Toolkit support virtual reality as well. Showing you the motion controller with the virtual reality and how it parallels to the hand ray and how nice that is. HoloLens 2 is not shipping with motion controllers. So this picture is just showing you that nice parallel. And there's a link up here that I'd highly recommend folks take a look at, aka.ms/mrtkdocs. This is actually where the Mixed Reality Toolkit team is putting all of our documentation on GitHub. It's actually parsed from GitHub into GitHub Pages. And it's got a lot of detail about how to get started with Mixed Reality Toolkit and also all of the different UI components that I've talked about here. So again, here's the same link. And wanted to point out one specific scene in Mixed Reality Toolkit called the hand interaction examples scene. And the really cool thing about this scene is it's actually showing you pretty much all of the guidance that I talked about here with directly grab objects, press buttons to activate them, at a distance use hand raise. It's showing you all those UI interaction principles with a set of common UI controls that you can then copy yourself to use in your own applications. And we've got sort of all sorts of things here. And of course, in keeping with our principle of supporting both near and far interaction, everything here works near and far. And in fact, if you had a VR controller, it would work with VR too, which is kind of great. So yes, please go to aka.ms/mrtkdocs to learn more about Mixed Reality Toolkit. OK, let's get coding already. So let's actually start rebuilding the demo that I talked to you about. And sort of to remind ourselves of what we're going to be doing, so I can remind myself too. OK, so here we're going to make buttons. So let's look at this button a little more to understand it. So what I'm doing, you're not hearing any sound here, but we're playing a sound when the button presses and releases. We're also visually changing the state of the button on touch. It's a little hard to see, and we're doing a little bit of a pulse effect. OK, keep that in our brains. The other control we're going to make is the slider control. So this is the control that was sort of the most successful because it really gives you that tactile sensation when you pinch with your hands and move. And it's also going to be playing sounds as we move across and as we grab and release. And now you can also see that, importantly, that it turns bright blue when I grab it. And we're actually going to do one extra. We're going to have it turn blue when I hover near it. OK, so let's get right to it and go up into my Unity here. So here we are in the Unity game engine editor, for those that aren't familiar. And we've got a lot of stuff here already, because it takes a while to sort of import everything. But what we've done is we've created a new project. And then we've gone ahead and imported Mixed Reality Toolkit. So if you go to MRTK Getting Started, you'll learn how to do that. You just need to download 2 packages, Foundation and Examples, and then go to Assets, Import Package to actually import those 2 packages. So we've got that. And then we've got this demo folder with the finished scene, just so that you all can see what the finished product's going to be, and also a couple of prefabs that our artists have given us that have all these gorgeous meshes and buttons. OK, so let's go ahead and just get started. So we're going to make a new scene. All right, so because I'm using Mixed Reality Toolkit, it's actually going to prompt me and say, hey, you don't have Mixed Reality Toolkit configured for this scene. Would you like to configure it with a profile? Now, the profiles for Mixed Reality Toolkit is basically your set of settings. Mixed Reality Toolkit has a lot of stuff in it. You don't need everything always. And so this profile lets you basically enable and disable all the different systems that you want. For now, I'm going to use the default one, which is pretty much everything. And now you can see that in my empty scene, I've now got this Mixed Reality Toolkit object here. And that's how you know you have Mixed Reality Toolkit in your app. And then you've got a bunch of settings here, and we're going to go through that later. Now, I like to do sort of rapid iteration and deployment, so I'm going to go ahead and press play right now to see sort of what changed on that. So we're going to hit play, and right away we see this frame rate counter that comes from MRTK that's going to tell us if we're performant, because we always want to keep our apps running at 60 if possible. And then, this is cool, check it out, I've got a hand. I've got a fully articulated hand with that hand ray. I can move it in and out, I can press it. And this is basically emulating the articulated hands that you're going to get in the HoloLens 2. So even if you don't have a HoloLens 2, you can already pretty much develop your whole application here with these simulated hands. And we actually have ways to support multiple poses. You can record and support arbitrary poses and switch between them with different key presses. All right, so this frame rate counter is nice, but I kind of think it's going to get in the way for our demos, so let's go ahead and disable that. So to do that, it's actually part of the configuration, so I'm going to make a customized version of my configuration. And then the frame rate count is in the diagnostic system, so I'm just going to uncheck that box. And now when I hit play, it's going to give me the scene, my beautiful hand, and no diagnostic system. Awesome. Now, I like to do one other thing, which is I like to make my background black. It makes everything easier to see. So I'm going to go ahead and go into, this is like a little bit of a trick for folks, a little bit of a I don't know if it's an Easter egg, but I like to set the skybox to none. And now when I hit play, it's actually going to be black background. Boom. So now it's sort of, this is most of our scenes, like the hand interaction all scene does the same sort of trick. All right, so buttons. Let's get started on that. So for that, I'm just going to drag in my button prefab. The prefab is basically like a pre-made set of controls that you can sort of copy and paste around. And let's have a quick look at this panel. So this is the overall panel. I've got my large and my medium buttons. And then in here, I have this thing called the button component, and that sort of has all of the logic for doing it. Now, I'm just going to cover sort of the parts that make up the button component, and then we're going to actually hit play and see what we get. So for the button component, we want to have our collider here. So this collider is going to give us the region that the finger is going to be tracked in. So when your finger is anywhere in this region, you're going to be getting touch events. So touch started, updated, and ended events, or pointer events. Pointer events are sort of our more general way to handle both near and far interactions and motion controllers, et cetera. We also have the near interaction touchable. Now, if you want to make a collider touchable, you have to add the near interaction touchable component to it, so our input system knows where to route the inputs. Otherwise, it would be sending it to all collidables, which would be expensive. So we can see that we've configured it to send touch events instead of pointer events. And then we're also specifying the forward vector of the touchable there. And that's sort of saying that the button is touchable from this particular angle. Right now, our surfaces are going to be touchable just from one location. We're working on adding sort of touchable volumes and et cetera. All right, so for the button itself, we can see a lot of stuff here. These planes are actually describing the different sort of events and stuff that happen. So the front plane here, the cyan one, is where the touch tracking starts, and then the blue one here is actually the maximum pushable distance of the button, so it will not go past that. And then the yellow plane is going to be where you're going to get that press event, and the red is where you're going to get that release event. So when the button goes through the yellow, it'll send a press event, and then back through the red, it'll get a release. And now you can listen to all of these events to give your user interface various kinds of feedback and do actions, like on-clicked event handlers and et cetera. So what we've done here is we've hooked up the events to an animation controller, and that actually our artist hooked it up. And the animation controller is actually going to change the visuals of the button to make it, for example, light up when you touch, and then when you press to do that pulsing effect. Also, we're hooking it up to play sounds when the button gets pressed and then released. Okay, lots of talking. Let's go ahead and see what's actually going on here. So I press play. I can use the WASD keys to move around. I've got my hand ray, and then when I actually move up, I can actually see that when my finger touches it, it lights up, and then when I press, I get a pulse, and then a release, I get a second pulse. And with audio, you can actually hear like the press sound and the release sound. You can see the pulse a little bit better here. So press event, presses a pulse, and then release does the other pulse. Let me show you something cool. So how about we make that button right now? You sort of have to press in pretty deep for the press to happen. Let's actually make it sort of press right away. So to do that, I'm going to go ahead and make these planes editable. I'm actually still in the game, editing the scene directly. And I'm going to move up the release, the press planes, and the max push distance planes so that they're much closer to the front. So if we take a look here, now basically I shouldn't have to move the button at all, basically, and it should activate. So let's go ahead and do that. All right, so moved them up, still in the game. And now I get that press event, and I don't move it very far. And even when I keep moving my hand, I'm basically scrolling, it's still not going in. So that sort of shows you the max push distance. And also how nice it is to edit in Editor, because you can change parameters live in your game and iterate really quickly this way. And this is why I love the fact that we have in-editor simulation, because having to build and deploy this every time would be very time-consuming. So it's really useful to have these sort of things. And the nice thing is when you stop the game, it sort of resets everything back to where it was. All right, so we have our buttons. Now let's go ahead and add the sliders. So I'm going to drag in my slider prefab here. Oh, it's a little close to the button, so let me just move it over. And now let's see actually what we get out of the box for the slider. So I'm going to just go ahead and press play. And now I can move over to my slider and bring up with the, by the way, to bring up the hand, I'm pressing and holding the space bar for the folks that don't know. And now when you can see that when I get near, I'm sort of hovering to indicate now if you grab, that the slider when you move, that it would move the slider, and you can see the text value here updating. So let me actually show you what's going on. Oh yeah, let me show you one cool thing. So I talked about near and far, and again, because we're using Mixed Reality Toolkit, we get all of that near and far manipulation out of the box. So everything here that's handling pointer events are going to work both near and far. Okay, so let's take a look at what's actually going on with the slider. So the text is basically has a script that's essentially just changing the value of text based on when a method is getting called. And then what we're doing is whenever the value of the slider gets updated, we're telling the show slider value script to basically update the text. It's pretty simple. And we've also got events for when the interaction starts and ends, so when you grab and release. And when we start hovering that thumb and unhovering it, we're also, again, changing animation states here. Now, the thumb is actually configured here, so we're telling the slider component that this is the thumb that you're actually going to be grabbing, and it's moving along a track that's configured here, the start and end. Now, let's look a little bit at that thumb to see what's going on here. So in the thumb, kind of deep in the hierarchy, and it's sort of set up this way because this is how I got it from the artist, but it's actually kind of nice to separate all these things out. We've got the box collider, and this is actually the object that's receiving all those pointer events. And it's grabbable nearby, so you can reach out and directly grab it. And also, the collider gives you that region that can be then interacted at a distance. So when the hand or the ray grabs this component, it's actually sending a pointer started event that bubbles up all the way to the pinch slider. And then this script actually handles it, does the math to figure out, as you're dragging, to project the slider route down to the axis of interaction and move it and send the updated events. And we've also got the slider sound script that's actually, again, listening for these events and then playing sounds on grab, release, etc. We are absolutely publishing this online, and it'll be much easier for folks to look at the contents when we're there. So that'll be much easier. Now, another cool thing is we can actually just change the start and end of the slider live. So let's say I want it to be short, and again, we could also change the visuals by changing the track visual scale here. But now, sort of if I update it, we're just going to be able to, I'm getting close, so I can move my hand, but it's only sort of moving this short distance. And if we wanted to, we could also sort of change the axis of the slider by having it move along the y-axis here. So now it's going to move vertically and probably look very funny. But hey, there we go. All right, so lots of stuff that we can do with the slider. And we can interact with it at a distance, which is great. Now, I want to do one more thing, which is the hand rays look really cool, but for our demo that we're going to show you when we're running live, it's going to get in the way. So let me just turn off those hand rays. So to do that, this is, again, a Mixed Reality Toolkit configuration. I'm going to go ahead, and it's in the input system in the pointer settings. So I'm going to make my own input system, and then customize my own pointer profile. And then in the pointer profile, the rays are basically called the default controller pointer. So all of these inputs, so Oculus, the Vive, Windows Mixed Reality controllers, are all going to create rays. And right now, articulated hands also create hand rays. So we're just going to uncheck it so that now articulated hand is not making the rays. And now we're not going to have any far interaction with the hand rays. So you can see I move away and I don't see it. So now we can sort of do that. Now, I also want to be able to turn off this hand visualization when I'm running live. So for that, I'm going to use the toggle feature panel. So that's a component that comes in for free in Mixed Reality Toolkit here. And then let me just bring it a little bit closer. So here we go. So now it's going to let me turn off and on the visuals. All right, so there's the panel, and then I can, let's say I want to turn off the hand joints visualization. So I go here, and then now, boom. Now all we see is that nice little ring cursor that gives you that proximity. Okay, whew, that's a lot. I think now sort of I've tested everything. It seems to be working. This is my normal flow. Now I'm ready to go on to the HoloLens. So to do that, I'm going to build my UWP solution here.
Hey, Julia.
Yeah.
Before you do, actually,
Yeah.
question.
Uh-huh.
So we tried this out, and I feel confident. Do you want to try using the device to project?
Oh, you want to film me using the phone? So instead of that big expensive rig that we had on HoloLens 2, we're going to just film me doing the HoloLens interactions, and you're going to see it on your phone.
Yeah.
Okay.
You want to do it?
Yeah,
All right.
Let's give it a shot. So what do I need to do?
Okay, so go to Mixed Reality Toolkit sharing. There's your prefab, spectator view.
I just need to drag in the spectator view prefab?
Yeah, and then I'll come over to my Mac and I'll explain the rest.
All right, sounds good. Let me go ahead and start compiling it.
All right. So with Mixed Reality Toolkit, we're building out a couple of pieces around sharing, and I'll get to that a bit more later. And one of the pieces is spectation. So I have the same project here, and I need the same project from Julia because I'm going to be relying on the same meshes. However, I don't need the same scene. So what I'm going to do is basically, I'm going to build a scene for a AR device and drop in the spectator view prefab we have building out in MRTK. And let me just go ahead and do that. And then prefab. And we're going to switch to spectation. All right, so what this is going to do, this prefab works off of local network. The HoloLens, which has a host version of it, will act as a host, and then the phone will connect to it. And then I've configured Azure spatial anchors here, and we're going to use that to localize. If you're unfamiliar with that, who here has actually attended the spatial anchors session on Monday? Great. All right, so for those you who haven't, it's basically a service running in the cloud that allows you to share location between multiple devices, between HoloLenses, ARCore, and ARKit. The way it works is basically HoloLens will create a spatial anchor in its understanding of the world, serialize that data, and communicate with the service. My phone afterwards will also communicate for the service, asking for the spatial anchor, and the service will figure out where the phone is in proximity and send that information back. Once we have this, once we have agreed on the world position relative to each of the coordinate frames, we can start synchronizing data. And again, so this scene is empty because the code we have built up will regenerate the scene based on what Julia is running. I'm actually going to skip the compiling step because we have all the wiring hooked up, but you can try it out for yourself later this month, this exact code. All right. So just going to enter my IP here. So the IP of the HoloLens, which was 70.66. All right. So we're going to connect. All right. And now it should be localized. Yep, there we go. All right.
All right, I'll give you guys lots of time. So this is, got to say, really a dream come true for us because we really wanted to create this using tools that are freely available to our developers and just the phones that they have in their pockets instead of needing a custom setup or anything. So it's really special to get to share this all with you and let you guys take videos.
Yeah, and it's great. I mean, we see what Julia is doing. We can participate right now in spectation only. With this. And this is real code that's running that's going to be in Mixed Reality Toolkit shortly.
Do you want to take a screenshot?
Yeah.
Share it out?
What do you guys feel like? We're going to take a screenshot, post it on social media? Yeah? Let's do it. All right. I'll post it later. Hashtag MRTK build 2019. All right. So, is that awesome? Cool. Let me get back to the slides here. All right. So, I talked about spatial anchors. For more information on that, go to aka.ms/spatialanchors. It's an amazing service. It will allow you to do a lot of shared experiences. Speaking of which, remember at the start I said that mixed reality computing is a blending of digital content with the physical world. So we have holograms with HoloLens 1. We have instinctual interaction with HoloLens 2. And that was what Julia was doing over there, interacting with the holograms, except that was left out. So this sharing where HoloLens can interact and in a shared session with any other device, be it an ARC or ARKit, is what we strongly believe in. And there's many applications out there that currently embed this into their application. What we're doing with Mixed Reality Toolkit is we're building the proper support to allow developers to enable full sharing capabilities in any application. What you saw today is real code that's running. It's expectation, one-way synchronization, and it will be available very shortly. And that's only the tip of the iceberg. If you want to learn more, go to aka.ms/mrtk. It is our GitHub repo. You can consume our code from there. You can interact with our developers. You can reach out to me, Julia. You can also submit feature requests or implement the features yourselves, and we will code review it and work with you to get it in. We simply love engaging with our passionate community, a passionate community of developers that are excited to build with MR. And we're excited to build with the developers like yourselves the future. Thank you very much.
Yeah. Also, if you guys follow us on Twitter, we'll be announcing when we're going to post all the demo code that we saw today. We're working on cleaning it up and getting it up all ready for you all. So yeah. Any questions?
For questions, please come on up to one of the mics. There's several in the middle. Who here is enjoying build? That's the most important thing. Yes.
Yeah, I have a question about WebXR, WebVR. Is there plans to have support in the toolkit for WebXR?
I think we're investigating that right now. Could you actually open up an issue on the GitHub page, and we'll follow up there?
Sure thing.
Yeah.
Thanks.
Cool. Awesome.
Yes, is voice commands kind of built in, or?
Voice commands?
Yeah.
Yes.
Yeah, it's in the speech configuration profile. You can add any voice commands that you want and map it to these things called actions, and then there's a speech command handler, and you can basically listen to specify which voice command you want, and it'll respond.
Great, thank you.
Yeah.
Yep. Go ahead.
Could you share any of your experiences that you had when you're creating like two-dimensional holograms? So for example, like how is it different to handle the interactions with like the 3D holograms that you showed versus say like a three-dimensional rendering of like a 2D web browser? Like
Yeah.
Yeah. So,
I've spent a long time on that. So actually, in the MR Dev Days talk and interaction crash course, I go over a lot of the prototypes that we built because it's actually, so a couple points on it, and I shared learnings there. One super interesting, so first of all, the basic principle of it sort of following touch interactions. So if you treat it like a touch screen, that basic principle works well. But there's a lot of details in the implementation. So one thing that can be challenging when you have a very flat, bright object is it can be sort of hard to see where your hand is relative to that object. Now you can render the hand on top of it, which of course we tried. The problem then is that you're occluding the content, like the web browser content that you want to see. And so, but because you can't see your hand, it can be kind of hard to know when your hand is pressing the content. So what we do is that finger cursor that you sort of briefly saw in Mixed Reality Toolkit, which is a ring that kind of shrinks in size to communicate both the location of the finger and proximity to the slate. It's basically like an aiming aid, so it actually helps you click on really small links. And we actually have this problem in the shell, like we have to have people use Edge. So it's like the hardest possible problem that we have. So the other thing that works, that's critical, is to have a shadow projected onto the slate. So it's basically a shadow of that cursor. And so then what the eye does is it sort of uses that connection between the decreasing radius ring and the shadow to know when you're touching. Then to further communicate that you're contacting, we play a pulse and we do a sound. And then on top of that, we have to adjust the dead zone sizes that we have for the scrolling, touch, versus clicking disambiguation of the 2D UI to make them larger. And there's actually really interesting observations that we had for hand movements, because when people click air, their hands are actually moving in arcs. So they do these sort of arc motions, which means that they move a lot. If you project it down into the plane, they move a lot in the XY plane. So it's challenging, but doable. So that's the long answer. I just like talking about that kind of stuff, so sorry.
Go ahead, please.
Yeah, do you have any future plans to create sort of like haptic feedback gloves to kind of solve some of the problems of people moving through the buttons?
We've definitely researched it. I'm not aware of any plans that that I can speak of, but I'm not aware of any plans, but I've looked into it a lot. I know there's a lot of really active, very interesting research in that area. My main task when I was thinking about how to do this for the shell was knowing that that's like an extra piece of hardware is, can you get away with not having it? So the answer was yes, but the haptics is definitely an active area of research.
Go ahead.
I was just wondering, does it work with Unity's default UI system? One of your slides showed that. And
Yeah.
So do you have to do anything to make it work, to like set it up?
Do you want to take it, or do you want me to take it?
No, go ahead.
Yes, it does, actually. We had a contributor from a partner team actually make it work with the Unity UI system. And so actually, if you add Unity UI Canvas, as long as you're using Mixed Reality Toolkit, I believe it'll just work. It's actually pretty cool. I mean, I could run it on the hand interaction scene, example scene, but you can basically, it'll work at a distance with the raise and with if you directly touch it.
That's really cool.
Yeah, thanks.
So I have two questions. The first one is, why did you guys replace the bloom with the wrist tap for the start menu? What was the thought there? And the second one was, is there any support for radial menus around a closed fist?
Okay, yeah, I can take the bloom versus wrist tap because I spent a lot of time on that. So very quickly, we realized it almost instantly with the very first prototype where we stuck a leap motion onto a HoloLens, and the first thing people do is they go like this. And that blooms you instantly. And then even when people get past that sort of amazement, when you grab and release something, half the time, you do accidentally do a bloom gesture. And furthermore, we got a lot of feedback from a lot of our customers that when they're just doing tasks in their app, so my favorite example is like in medicine, somebody was like training how to give somebody a shot or something, and they would just like let go of whatever they were holding and it would bloom. So there was a large number of false positives. So we needed something that was more constrained than the bloom. And we also wanted to do something that was a little bit more following, instead of a symbolic gesture, more of direct manipulation. So originally we actually thought we couldn't do the wrist tap because we thought we couldn't do two hands close to each other, but then the hand tracking team figured it out. And this is why we sort of went with a button here. And the idea behind the UX of it is we found that people really like menus around their hands. And I've seen designers prototyping the radial menus around the hands already. So I believe there's no like radial hand menu component, but you can do it with like a solver component. But that's great feedback, and that would be great to have an issue around, hey, we want a hand menu. And so the UI system is that sort of anything below the wrist is system, and then anything above the wrist is sort of the app has for their menus.
Thank you.
So to that point, Julia was referring to actually solvers built into MRTK. So you can you download it today and actually try out the radial menu, as long as you follow the guideline of putting it above the wrist. Hello?
So quick question is, what do I need to get started? That seems pretty cool. I have nothing but a laptop and Visual Studio at home. What do I need?
What do you need to get started with a Mixed Reality Toolkit?
Yep.
Yeah, good question. So you need Unity, right now we recommend 2018.3. You need to download actually, go to our aka.ms/mrtk. On the first page in the README, it details you exactly, so you don't have to remember it all.
Yeah. We have a getting started page, but it's that, and then there's this Windows SDK 18362, which is now, if you just get the latest update, I believe it's included, so you don't need to install like a preview Windows. But actually, you don't need Windows SDK to do the in-editor simulation.
Yeah.
So all you need is just Unity, like you can even do like a personal license of Unity.
Okay, thanks.
Mm-hmm. All right. Oh, one more.
Going back to the wrist option, are there any other modalities that people can opt in if they only have one hand, for example, or if they need to work with on the other hand?
Yeah, absolutely. So this is I'm very passionate also about the accessibility of that, and so we are very actively sort of planning to support a one-handed option, and it's actually funny because that one-handed option is sort of the one that we started with, and then we went with this two-handed thing, and now we're going to support sort of a hand up. When you bring your hand up, there'll be a little icon here that you pinch to open. So we're actively working on that, and we're planning to release it really soon in like the very first update. So it's like a timing thing for us.
Hi there, Julia. Has there been any work done on a taxonomy of interactions in AR? Maybe it's a dissertation that we should suggest to someone, but has that conversation started anywhere?
I sort of personally try to collect these interactions myself. So there's a website that sort of is collecting AR and VR interactions. That's sort of a student created. I wouldn't say that there's like one like definitive guide that I'm aware of. There's also research papers that talk about, you know, given they do these like elicitation studies where they say, how would you do this gesture to close an app? And then they record the 5 different ways that people want to do it in the air, and then they sort of try to come up with a gesture set that way. I've seen a lot of those, but I haven't seen a really detailed taxonomy, except for the ones that I've personally worked on, haven't yet published.
On my wish list.
Yeah, okay. It would be really fun to do.
Hey, that's pretty cool. And my question is there any machine learning in the system that kind of learn your gesture in the way it gets to use your way of doing certain things?
We do have some machine learning in the hand track. I mean, our hand tracker is based entirely off of a deep neural net to sort of segment out the hands from the background and also to align the depth mesh to the hand pose. We also have, it's also learning the size of your hand. But as far as gestures go, it's a great idea, and it's like an active area of research and something we really want to include, which is sort of personalizing the gesture recognition. For now, we're sort of just scratching the surface. I can't emphasize that enough that we're just getting started with all this. So it's sort of active area of research for us. Yeah.
What can you tell us about eye tracking, and perhaps not just the technology, but sort of the ethics and privacy concerns around that?
Mm-hmm. I can take that one, or you can take it too. You want to take it?
Go ahead.
Okay. We actually have, first of all, we support eye tracking in HoloLens 2, and second of all, we're actively supporting it in Mixed Reality Toolkit, and we have some really awesome examples that Sophie Stelmach has been working on to show you how like effortless eye tracking can be and how it can make it feel like it's really reading your mind. She's made a lot of examples in Mixed Reality Toolkit. She also has a really great talk that gives a lot of detail about the implementation of it. And as far as the ethics question goes, I know that I can't speak to it directly because I don't know, but I know we're actively, like it's an active, like very important for us to make sure that we're not sharing that sort of data anywhere. So I know that we're actively caring about that.
Microsoft has a very clear Windows privacy policy, and I believe if you reach out to us online, we can direct you to exact details for eye tracking.
All right, thanks.
Thank you.
Is it possible to simulate the eye tracking with an external camera or eye tracking?
We don't have it with the external camera, although it's a great idea. Like you could stick up a Tobii eye tracker, but you can simulate the eye tracking in MRTK. You actually just simulate it. It's the camera movements. You could just have it be, instead of the head, be the eyes. So there are ways to simulate it in Mixed Reality Toolkit, and then having external inputs is a really interesting idea.
Okay, it's on my wish list.
Okay.
Yeah,
I'll
actually,
wish you too. Mm-hmm.
submit a feature request to GitHub.
Yeah.
That's actually a pretty cool idea to use a camera for eye tracking simulation.
You showed HoloLens today, but where are you in regards to using your phone, ARKit, AR Core, and using the toolkit?
Right. So officially on the page right now, we're supporting HoloLens 1 to Windows Mixed Reality and devices based on OpenVR. What you saw today is we're looking at experimentation of how to go to other devices. Because, for example, for spectation, this developer workflow where someone is working on something and I want to very quickly participate and look at it and show it to the rest of the team is highly valuable. So there's going to be more details coming into how we'll support it, but this specifically at least will have spectation capabilities this month.
Yeah, just follow us on Twitter. We'll be posting the updates. The handles are right there.
Yeah.
For the HoloLens 1, you had research mode to access the sensor data. Is there something similar in HoloLens 2?
That's a good question, but I think that's outside the, we can direct you again. So if you reach out to us,
just
say
reach
on
out to
Twitter,
us and
we'll
direct you to the right
appropriate
person to officially answer the question. Yeah, it's a great question. By the way, Mixed Reality Toolkit does work with HoloLens 1, so all this stuff will work if you deploy it to a HoloLens 1 as well.
Cool.
Thanks a lot.
Well, thank you very much.
Thank you.
Enjoy the rest of your build.